All right, Marcel, I'm looking at number 73 or 2-73. A consumer magazine collected the following data for the fuel efficiency of cars, miles per gallon, compared to weight. So here's their weight, and you can see as the weight goes up, the fuel efficiency goes down. And all these little points are just data points. But what they did here is they put in a line that's a line of best fit. And the equation to that line is right here. It looks like they said E equals 49 minus 8.4 W. So this is just kind of would give you like the average amount. So you should plug in a weight and you simplify this out and it'll tell you it's the average fuel efficiency for a car that's that heavy. So what does the negative 8.4 in the equation represent? Well, if you look at it, like whatever the weight is, you multiply by negative 0.84 and then you add 49 to it. So there's a couple things. One, if you look at this line, that's kind of like the slope of this line where, you plug in a W and it goes down. So, if it's like, if you plug in 2,000 pounds, you got some weight around here, or sorry, some fuel efficiency around between 30 and 34. But then if you plug in 3, so you plug in one more, it's going to go down about 8.4, which means now your fuel efficiency's, if we were at like 32 minus about 8 is about 24, and that's about where we are right here, right? So it just kind of represents the slope or the change in miles per gallon per 1,000 pounds. So that's really what slope is, right? It's the change, and change we usually use the symbol delta. So this 8.4 represents the change in miles per gallon over the change in, I think they're using weight here, so I'm going to use a W. And they actually use E for miles per gallon, so it's almost like the change in E for efficiency over the change in weight. And that's really what slope is. If you think about a line, we call the slope the change in Y over the change in X. Or you might have also seen it as something like rise over run. That's really what slope is. It's just the change in height over the change in X. So that's what the 8.4 is. Second part B, what does the 49 in the equation represent? Well, this line doesn't perfectly match what they're saying here for 49. Well, maybe it does if you were to go all the way to 0. But basically what that is it's your y-intercept. If you were to follow this line all the way back to 0, this graph doesn't go back to 0. But if you would, when it hit the 0, which would probably be somewhere over here, it'd be around 49. So that means if the car was, and obviously this is not perfectly accurate because it's not actually a line in real life, but if the car was 0 pounds, which isn't possible, it would get 49 miles to the gallon. So a line really isn't the best fit for this data. In fact, probably the best fit for this data, if you had some graph, probably the best fit for this data would be some type of curve like this. But they're saying, hey, we're going to just estimate it using this line. And you get pretty close using that line. But where it breaks down is at things like 0, because obviously you can't have a car that weighs 0 pounds, right? Yeah, so that's the part B. And then C, describe the association between fuel efficiency and weight. So again, that's kind of like what part A is, but I kind of talked about that here. And think about what happens as weight goes up. How does that affect fuel efficiency? How about as weight goes down? How does that affect fuel efficiency? D, Cheetah Motors has come out with a super lightweight sports utility vehicle that weighs only 2,800 pounds. Well, 2,800 pounds would be right around here, right? 2.8 thousand pounds, 2,800 pounds. What does the model predict the fuel efficiency would be? So you should be able to, if this is about 2.8 or 2,800 pounds, you should be able to use this model to figure out what that fuel efficiency would be. All right, so that's for that question 2-73.